matter is that related to? Derivative, okay? Got it? So you got the equation sheet, you will get copies just like this on Monday. Know which equation is for what purpose. Fall into the trap of using the wrong equation. Any questions on that? Okay. So I have up there, got created last night, the chapter practice exams. So I highly suggest that you take advantage of them, take them more than once. So be prepared for the exam on Monday. So the only thing you'll have to worry about if the Thanksgiving break is the next class. All right, any questions? I just have questions on exam 4. Okay. So let's jump back in. We were talking about TCP/IP, transmission control protocol / internet protocol. And again, the internet is referring to interconnection of networks. That's a term that preceded what we now know as the internet. The internet basically was taken from that, but this came first. So what it basically means, these are two separate protocols, but they go together. TCP handles host-to-host communication. That means establishing a connection between your PC and Google. And then the IP portion of it allows exchange of datagrams across network boundaries. We have the network that we have here at USI. We get a connection through AT&T via fiber to its network, which will eventually get you to some local, wherever the nearest Google server would be, etc. So remember the OSI model, the 7-layer model. So this is at least, admittedly there are different interpretations of how the TCP/IP model should line up with the OSI model, but here's one of them. So first of all, the TCP/IP does not exist down at the physical layer. It makes no mention of how bits are supposed to be sent, what cabling is supposed to be used, etc. That's not part of what it defines. It has a link layer, which pretty much lines up with the data link concept in the OSI model. The internet layer basically lines up with the network, and then the transport lines up with the transport. Above that is what would be considered the application. And so where the OSI model lists that between session, presentation, application, that's kind of just one layer as far as TCP/IP is concerned. Again, does it really line up this nicely? That's debatable. As I said, there are other interpretations of exactly how those things compare. Okay. So a little bit more about TCP. So we want to deliver bytes. So the smallest unit that gets transmitted over, say, Ethernet or TCP/IP is a byte. Now, of course, you have bits within the byte, but that's the smallest rational form of data that gets transmitted. And so what TCP tries to do is to provide a reliable, error-checked sending of the data. That means that there's a checksum that goes with the bytes being sent, so that on the other end, you can compute the checksum, compare it to the checksum that was transmitted. If they don't match, then clearly there is corruption in the data. So you would know that there is corruption in the data. So that's what the error check means. Connection oriented basically means that, before node A can send data to node B, they have to establish connection. That's like the other guy goes, okay, I'm ready to receive, and then data goes. Okay? You just don't send data without making a connection. So the terminology about the grouping of data would be a segment. So I forget how many bytes that is. And then things are typically sent between ports or internet sockets. So for example, back before, these days, pretty much any of our web pages we're going to are using the secure version of the HTTP protocol, a hypertext transport protocol. That's how web pages are done. Before before the prevalent use of secure versions of that, port 80 was kind of the common port to be used. Of HTTP over secure sockets layer, or these days it's I forget what the TLS stands for, but that's the security or encoding protocol that's primarily used. That's port 443. Now that's pretty much transparent to users. If you just type in a URL, in fact, you wouldn't have to type in the full URL. You could say, en.wiki.org/wiki/transmission_control_protocol, and it would figure out this leading part. Another thing that happens, we're talking about dynamic naming server, how it figures out the IP address of where that is on the other end. Because in order to send the data, you got to have the IP address on that end. So the IP layer, so the so-called IP addresses, that's where these things live. So datagrams is the term used for the stuff that's sent. And it has a routing function. This is what enables the internetworking piece. So what routing means is that, if I want to send data from here to here, it doesn't necessarily go in a straight line, so to speak. It may bounce to a number of different nodes before it gets there. That's part of the whole reason why the internet exists. Remember the other day I was talking about, this originally was an ARPA and DARPA project in the military. That they wanted the ability that, let's say our site gets nuked, we can still get, other people can still get data around between installations because it doesn't have to go in a straight line. Unlike if you make a landline call, that is a connection-oriented thing where it actually has to make the connection from one established connection from one end to the other before the call then allows you to proceed from that point. Traffic over the internet, not so. You just send it out, and there are algorithms. Actually, grad student, I had to learn that algorithm. It's actually kind of interesting how it works, but stuff gets calculated, figure out shortest paths, and manage to get packets from one to the other. In fact, a given message that you send may not all go the same route. It could get split up, married back up at the other end. It's all matched. All right, so again, data is sent as packets between source and destination, and again, source and destination have IP addresses. So again, you've got these links here, people that dive deeper on the protocol. Okay, so how does this stuff relate? Throwing around all these multi-letter acronyms, abbreviations, TCP, IP, Ethernet, Wi-Fi. What's it all mean? Well, Ethernet and Wi-Fi are defined at the physical layer. That's how data is actually sent and received. Talks about, again, the physical cabling, how bits are sent, symbols for all of that jazz. TCP then sits on top of that, with either Ethernet or Wi-Fi,